In this lesson, I will show you a basic circuit analysis where we calculate for current, voltage, and even equivalent resistance. If you're new in this channel, you can subscribe to get notifications for every new videos I upload. It is actually better if you watch the video on the link below so you can understand the principles behind its equations. Quick review. In series circuit, currents are all the same while voltages are divided and the equivalent resistance is the sum of all individual resistances. In parallel circuits, voltages are equal while current splits into junctions. The equivalent resistance is 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R3. First circuit, we have a series connection and we want the values of all currents, voltages, and equivalent resistance. IT flows from the battery. We'll call it I3 here, I2 here, and I1 here. Voltage V is the source. V1 is here at R1. V2 is the potential difference here at R2. And V3 is the potential difference at R3. Before doing anything, let us first try our circuit in a simulation. Our currents are all 0.75 amperes. The resistors are, let me show that, 3, 9, and 4 ohms. Voltage source is 26 volts, so it's 12. V1 is 2.25 volts. V2 is 6.75 volts, while V3 is 3 volts. Bear in mind that our solution must agree with these measurements. Back to the circuit, because IT is equal to I1, I2, and I3, then we solve for IT first. From Ohm's law, we know I equals V over R, but we don't know RT. But it's series, so RT equals R1 plus R2 plus R3. That's 3 plus 9 plus 4 equals 16 ohms. Now, we go back to IT, that's 12 volts over RT, 16 ohms, so 0.75 amperes, which is also equal to I1, also equal to I2, and I3. We just solve for RT and currents. For the voltages, we use Ohm's law, starting with V1 equals I1 R1. 0.75 multiplied by 3 is 2.25 volts. V2 equals I2 multiplied by R2. That's 0.75 times 9 or 6.75 volts. On the other hand, we will use another technique to solve for V3. Because it's in series, then V3 must be the difference between 12 and the sum of V1 and V2, or 3 volts. You can check your answer by adding all these, which must be equal to 12 volts. Circuit number 2, we have a parallel circuit. It follows that currents split into junctions while all voltages are equal. So, we can now deduce that this VT, V1, V2, and V3 are all 12 volts. Now for I1, that's simply V1 over R1. 12 over 3 is 4 amperes. For I2, it's V2 over R2. That's 12 over 9, 1.33 amperes. And for I3, that's 12 over 4. That's 12 over 4 is 3 amperes. Now we can already solve for IT, but let's start first with RT, or the equivalent resistance of the circuit. That's 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R3. can already use your calculators to solve this one, but I will show manual calculations to help you improve your mathematics. Now that's 25 over 36 equals 1 over RT, and RT is 36 over 25 or 1.44 ohms. Finally, we solve for IT. It's VT over RT. 12 over 1.44 is 8.33 amperes. You can check your answers by adding I1, I2, and I3. It must equal 8.33. Circuit number 3. Here, we mix series and parallel connections. We can see that R1 and R2 are in series. You can imagine turning off one of them, and the other bulb turns off as well. But let us first pick at what we're looking for. IT should be 2.71 amperes. I3 is 1 ampere, while both I1 and I2 should be 1.71 amperes because they are in series. VT on the other hand is of course 12 volts. V3 is also 12, while from this point up to this point is 12 volts. VT is 5.14 volts, while V1 is 6.853 volts. Let's go back to our problem, and our strategy would be to simplify the circuit into the ones we already know, pure series or pure parallel. Start by combining R1 and R2. They're in series, so 7 ohms. Then we have a parallel connection between 7 and 12. Let's combine them to solve for RT. 1 over RT is 1 over 7 plus 1 over 12. You should know now how to solve this one, and you should come up with 4.42 ohms. Now we can solve for IT. It's VT over RT. 12 over 4.42, that's 2.71 amperes. IT and RT check. Since we have a parallel connection, then voltage here must be 12 volts, and here is also 12 volts. Now we can solve for I3. It's V3 over R3, or 12 over 12 is 1 amperes. In the 7 ohm resistor, the current is 12 over 7 or 1.71 amperes. Now we can work backwards and see that 3 and 4 ohms are in series. So currents are equal, 1.71 amperes. For B1, it is I1R1 from Ohm's law. It must result to 5.13 volts. For V2, it's I2 multiplied by R2. 1.71 multiplied by 4 must give us 6.84 volts. While V3 of course is 12 volts, we know that. And problem solved. Circuit number 4. Again, we have a mix, series, and parallel connection. Let us first cheat on and look at the future. If you try to turn off bulb 3, bulb 2 is still on. If you turn off bulb 2, bulb 3 is still on. So you know that the connection is parallel. Remember these values and let us compare our result afterwards. This is also one way of checking if you're calculating it right. Going back to the problem, let's start by simplifying the circuit into what we already know. Let us call the equivalent resistance between R2 and R3 R23. Since they are in parallel, then 1 over R23 must be 1 over 12 plus 1 over 4 equals 3 ohms. We now know VT and RT, so we can now solve for IT. That's V over R. 12 over 6 is 2 amperes. IT, RT, check. V1 is equal to I1 multiplied by R1. That's 2 times 3, 6 volts. While V23 is equal to 2 times 3, 6 volts. R2 and R3 are in parallel. So therefore, both are 6 volts. And for I2, it's V2 over R2. V2, 6 volts, R2, 12 ohms. That's zero point 0.5 amperes. And I3 is V3 over R3. V3 is 6 volts over R3, 4 ohms, 1.5 amperes. And I1, of course, was 2 amperes, as we already know. So that's how we analyze circuit. We just simplify them into series or parallel because we are sure that for parallel, voltages are equal, and in series, currents are equal. Even if you face a more complicated circuits like this one or this one, you can use the same technique. Next video, we will try to solve for other circuits, a more complicated one.